Hey everybody, this is the first video on this channel. Today we are going to be talking about the fundamentals of calculus. Now, when you enter calculus, it might be hard to say, but the first lesson is probably going to be about just functions and whatnot. But you guys already learned that in Algebra 1, Algebra 2, and Geometry. So now, we're going to talk about limits today. Now, before we even get into limits, we need to understand what is a limit in the first place. Because if you think about limit, oh, maybe it's just like the stopping point or wherever it goes up to. You're very close, I'll tell you that. But a limit, the limit definition, right, is that it describes the behavior of a function. Let me write that down here. A limit describes the behavior of a function or sequence as its input approaches a certain value. Now, this may be hard to understand because it's in such descriptive language as it pertains from Google, right? And what it's basically saying that as the x value approaches whatever value you're approaching, right? So let's say if x approaches 4, then what is the y equals? Now, it doesn't necessarily mean that, oh, if the function is f of x and x is approaching 4, we can just do f of 4, right? But we have a certain notation for it. And this certain notation is written as the limit, we write as lim, right? As x approaches a. Now, a is whatever value that you're trying to approach. So it could be 4, 2, -4, -6 of f of x equals L. In this case, L is the letter for something that's you're approaching. So that's the y, right? And now, when we take a look at this notation, it looks a bit funky, weird. We've never seen it before. But more practice, you guys will get it, right? So now, we read that as the limit as x approaches a of f of x is equal to L. So now, you're telling me, how do we even solve this out, right? Or, let's start with something easier, a graph, right? So now, we're going to try doing a graph here. We got the y-axis, and then we got the x-axis. So now, I'm going to tell you one thing, there's a more formal definition of a limit, which is called the epsilon delta formula, but the epsilon delta definition, I mean. But we're not going to be talking about during this video today because it's more a bit complex. So I just want you guys to grasp the basic data right now. So now, we're going to try to do this, okay? Let's draw a random graph. I'm not going to. Let's do this, and then let's make a loop down here. Okay, so this is our basic graph. Let's call this f of x with the x and y axis. So now, at this point on the top, we're going to say that this is 5. And then on the y-axis, it's going to be, like, what, 10, right? So now, let's try to solve this out. The limit as x approaches 5 of f of x is equal to what? So now, take a moment for yourself and try to solve this out and see if you guys can get it on the first try before even me explaining everything. You can pause the video here and yeah. Okay, so assuming that you guys just paused the video and did all the work, it's very easy to see that, oh, the value is 10, right? That's the reason that we're going to be doing limits for. So in this case, if I can erase it, okay, doesn't work that well yet. I'm still learning it. But the limit as x approaches 5 of f of x is equal to, you guessed it, none other than 10. So now, this is what it really means. It could go on either sides, just that it also works with open circle. So whenever there's an open circle, it's like a gap inside the function. So let's say if I had an open circle, we're going to draw a really, really quick open circle at x equals 6. And then we're going to draw a closed circle down here. This is equal to 2. And then the top one, make dashes here. That is equal to 5. And of course it is 6. So now if I say the limit as x approaches 6, right, of f of x is equal to what? So now, a closed circle doesn't really mean that, oh, it's the limit. Because whenever you have a closed circle, it just really means like, what is it actually defined at that specific moment? So if we write the f of 6, then that's of course equal to 2. Because you can't, an open circle is just undefined, and there is no way that you can write undefined in math. So now, when we look at limits, we have to follow the curve. We're following the graph. So we're following the graph up and then down, back again, and we meet until this point. So that's the limit as x approaches 6 of f of x is equal to none other than 5. Okay, so now that's really what a limit actually means. So now now we have different ways of solving it. I just showed you the graph method. We also have a table method and also a algebraic method. So now, as I scroll down onto the page, let's try one of the table methods. So we're gonna write x, and then we can write f of x. So we can have 3.001, and then we can have 4. No, actually no. We're gonna have 3.9, 3.999, and then we're gonna just have 4.001 and 4.1. Just to make it easier for you guys. We're gonna write 5.9, 5.999, 6.001, 6.1. So now this is our table, okay? Now how can we find the limit as x approaches 4 of f of x, right? So now we're gonna look onto this graph. 4 resides in between here, right? I'm gonna use a different color. 4 resides into here, right? Right there. So now we're trying to look at the numbers. We're going from 3.999 to 4.001. We're really, really close. So we can make a little estimate. And in this case, the estimate would be equal to none other than 6. Because in between 5.999 and 6.001, it resembles a 6. So we can say that the limit as x approaches 4 of f of x is equal to 6. Now, we also said that there was another way to do this, and that would be algebraically. Now, this video we're only going to talk about just the basics because it's the start, right? And we're going to rewrite our notation here, but instead, we're going to do as x approaches 5 of f of x, right? And then on the side, we're going to say that f of x is equal to 5x squared minus 3, okay? And what we're going to say here is that we're just going to use basic substitution. And there's one key point that we always need to remember. We always have to remember to write the limit until you substitute it in. So this equation, we can write it as the limit as x approaching 5 of 5x squared minus 3 is equal to, and then this is where we start substituting in. So we can just directly write 5 times 5 squared minus 3. Now, if you use your calculators, we would all know that that would be 5 times 25 minus 3, and that would be equal to 125 minus 3, and then it's going to always equal to 122. That is our answer. So now, let's give you some more problems here. We're going to write this in blue. So now, try this. The limit as x approaches 3 of 3x squared plus 5x minus 6. Try that for yourselves. Pause the video here and try it. Alright, so now we're going to try to solve this now. In this case, we know that the 3x squared plus 5x minus 6 is our function, or we can call it f of x or whatever, g of x, h of x. And the way how we're going to solve this is by, you guessed it, substitution. So we can directly just substitute it in. So 3 times 3 squared plus 5 times 3 minus 6. So now we're going to start to solve this out. 3 squared equals 9. So 3 times 9 plus a 15 minus 6. That's going to be equal to 27 plus 15 minus 6. And that's, of course, going to equal to, let's see, 15 minus 6 is 9. So 27 plus 9 equals 36. And 36 is our answer. So that wasn't that bad. And once you get to more of the complex areas, it will start to tell you, hey, we're going to have to use different ways. And just as a repository, we're going to tell you that the next few are going to be like trig functions, trig identities. We're going to have factoring. We're going to have conjugates. So after this video, we're going to do all of those. And it gets more complex, and hopefully we all understand and we're going to be on the same page. So thank you for watching this video about limits, the basics of limits, and I hope to see you next time. And of course, do more practice on it.